What's up, guys? Now let's talk about GraphQL. Recently, we've been discussing a lot of different architectural styles such as REST, and GraphQL is another architectural style, and we're going to discuss why does it exist? What are the limitations of REST that led to the creation of GraphQL? What are its benefits? What are its drawbacks? And this will give us a good high-level conceptual understanding about GraphQL, so when you're making a design decision, you make a good one. So let's get into it. So a query language for APIs, GraphQL. And we're going to learn about GraphQL and how it's used to access multiple endpoints in a single query. So to introduce this, many client-server communication technologies have emerged over the years since the inception of the World Wide Web. And advancements in APIs over the years compelled developers to invent new technologies for fetching data from backend servers due to the limitation of existing architectural styles. So pre-existing REST APIs are insufficient to handle contemporary, feature-rich, and complex applications. So applications like Facebook and Twitter, they fetch user data from multiple different endpoints. And REST API proved inefficient for fetching data from multiple endpoints. So in this example, we have our client and it's fetching data from different endpoints, right? We have 1, 2, 3 endpoints. But in our GraphQL query, we just make one query to a GraphQL server and then it'll hit all of our different endpoints that we need and return one request. So we will introduce GraphQL and specify the essential components in a client-server communication. We'll identify some of the limitations of the REST architectural style that paved the way for GraphQL. So let's talk about REST's drawbacks. So in a REST API, we hit a URL and receive whatever data comes back. There are certain problems with how a REST API fetches data, so multiple request problem. A REST API sends multiple requests whenever data required by the application resides on multiple endpoints. So we need to fetch data from multiple endpoints with one single request. Then there's the overfetching and underfetching problem. In a REST API, the data fetched in a response to a single request is either very large or very small. It doesn't serve the purpose of the request, right? So we need an approach to fetch the exact amount of data needed by an application. So let's talk about the multiple requests problem. With a REST API, we fetch different types of data from different access points or URLs. And this causes us to send various requests to fetch the desired data. So for example, to access the starships, planets, and films data from an API, we need to make multiple requests to their respective endpoints, right? So for starships, we have, this endpoint. For planets, we have this endpoint, and then for films, we have this endpoint. And only after the successful fetching of the required data from multiple endpoints, the client can start rendering it. Right? So REST suffers from overfetching and underfetching, and overfetching is retrieving more information than we actually need. And then underfetching is when the fetched information is not enough for the application. The problem with overfetching is that it uses extra resources and may burden a server with additional load, and due to underfetching, the client makes more requests to the server to access the desired data. For example, the following GET request returns Starship data with the ID of 10, right? So we have a curl request and we have our endpoint, and the request receives the following data in JSON, right? So we get all this data back in JSON with our request. Underfetching occurs when a specific URL doesn't provide the required information. So clients make additional requests to fetch the required data. So this can lead to the N+1 request problem. So a client first downloads a list of endpoints and then makes one additional request per endpoint, right? Or for example, we need the pilot's data of the starship, right? And the client will first download the following links, then make a request to each URL mentioned below, So here we have an example of underfetching. So can underfetching lead to issues like overburdening the server? Underfetching can overburden a server due to too many requests to get the desired data, and the extra round trips to get the desired data increase our latency. And so GraphQL was developed to address the previous drawbacks in the REST API, and we'll discuss GraphQL and the way it resolves the problems that arise while using the REST API. So the emergence of GraphQL. GraphQL is a new API standard and a query language specification developed by Facebook in 2012 to handle these problems. And GraphQL is analogous to the SQL queries in relational databases, where we can build a query to fetch the required data from multiple tables. GraphQL works in a similar way for APIs to fetch data from multiple endpoints in a single request. So from a client's perspective, it will be a single request, but at the server side, we'll need to make many round trips inside the data center to different components like databases, caches, and so on. This isn't bad because latency inside the data center is very low compared to the latency between client and server. And a query language for APIs, it can be used in any context where an API can be used. It typically uses HTTP as the underlying protocol, although it's transport agnostic. And let's talk about the components of GraphQL. The implementation of GraphQL can be divided in two components, the GraphQL server and the GraphQL client. So the GraphQL server. The server takes our APIs and exposes them to the GraphQL client via an endpoint. It has two main parts. It has a schema, which is a model of the data that defines relationships between the data, and based on the schema, the server specifies what type of queries and data a client can request. Then we also have resolve functions. A schema can tell us what types of data a client can request but lacks the information about where the data comes from. And resolve functions specify how types and fields in the schema are connected to various backends, and it provides direction to convert GraphQL operations into data. So let's talk about the GraphQL client. The GraphQL client is the actual front-end component that allows us to accept queries. So you can connect to the GraphQL endpoint and issue queries to gather data. And it can be a single page application, a content management system, or a mobile application, and so on, right? So here we have our client, and it makes a request to the GraphQL server, and it's, talking to our backends, databases, fetching data, and our schema validates the data in the request. And let's talk about data manipulation using GraphQL. GraphQL offers us two types of operations, queries and mutations, and data can be fetched using queries. And GraphQL uses operations called mutations in order to insert new data or modify the existing data on the server. So this is equivalent to post, put, patch, and delete methods that we use in REST. And let's talk about mutations. Mutations in GraphQL are defined in a similar way as we define functions. So mutations also have names and selection criteria. Three types of GraphQL mutation operations are insert mutations, so we use to insert a new record on the server side, update mutations, we can modify existing records in the database, or delete mutations, which is used to delete a specific record from the database. So for example, the following mutation will insert a new student into the database after specifying values for name, roll number, and degree program. And add new student schema is defined on the server side, right? So this is defined on the server side, and add student is the function that a client can use to insert data in the database. So we can use this function if we want to add a new student to our database, right? So let's talk about GraphQL, the request and response format. A GraphQL query requests only the data that is needed. A query is defined using the word query, and inside it we mention other objects and the attributes whose values need to be fetched. So to the right, GraphQL query requesting the attributes name, length, and cargo capacity of the object Starship having an ID equal to 10, right? So the ID is equal to 10. We're trying to get some information about a Starship. And the response to that preceding GraphQL query is in JSON format that matches the shape of our query. So here we have our data, our Starship, and our name, length, and cargo capacity in a JSON format. So GraphQL queries can be nested. So for example, let's modify the query before and request the name, diameter, and climates of a planet having an ID equal to 5, right? So here we have this query from earlier, and then we have our planet query. And an advantage of GraphQL query is that we can request different types of data within a single request. So the following response now consists of the Starship as well as the planet data. So we have our Starship data and our planet data here. So how does GraphQL fill in the gaps from REST? So GraphQL resolves both the shortcomings of the REST API in the following ways. The multiple request problem. GraphQL allows us to access multiple endpoints in a single query, and this eliminates the first problem in the REST API. And a query accessing Starship, planet, and all films data in a single request. And instead of sending multiple requests using the REST API, GraphQL does the job in a single query. There's also the overfetching and underfetching problem. A single GraphQL query also addresses the overfetching, underfetching problem by accessing the exact information needed for an application. And is it possible to imitate the behavior of GraphQL by requesting only the desired data via REST? And the answer to that is yes. REST APIs use partial response strategy to get the desired data. So for example, we have a get planets endpoint, which will show us all the planets available on the endpoint. But in a partial request, we can use filtering and define some conditions in the request. So for example, we can do planets and get the result, find radius and gravity, which will return the radius and gravity of all the planets, right? We could do that. But if it's possible to fetch only the desired information using the REST API, then why is there a need for GraphQL? Well, the partial response strategy or filtering is a flexible approach to getting the required information via REST APIs from a single endpoint. But GraphQL benefits us the most in a case where we frequently need to retrieve the desired responses from multiple endpoints at the same time. And what are GraphQL's drawbacks? So GraphQL still has areas for improvement. It's more complicated to implement than REST and incurs extra complexities. From a maintenance perspective, there are three main drawbacks when opting for GraphQL. The first one being error handling. So REST provides us with a comprehensive response status and tells us about any errors that occurred. But in GraphQL, we need to parse the response to understand the error, and it increases complexity and adds to the user perceived latency. And then there's file uploads. So GraphQL specification doesn't include file uploads. Functionality is left to the developers and their choice of implementation. So using a mutation with base64 encoded blobs, which makes the request larger and more complex to encode and decode, allocating dedicated servers or REST APIs to upload the files, or using a third-party library such as GraphQL Upload. And also web caching. So GraphQL can work with multiple endpoints, therefore caching data at different levels is a little bit more tricky. And in summary, we explored GraphQL and the gaps it fills in REST. It provides a remedy for the problems with underfetching and overfetching in the REST API style. It enables targeting multiple endpoints in a single request that reduces the round trips between clients and servers. And GraphQL also comes with certain drawbacks and complexities, such as error handling, file uploading, and web caching are more complicated in GraphQL than REST. So hopefully you learned something, and thanks so much for watching.